PDF version. And
If it's easier, I'll use the line.
no, it's fine. Okay, so for you, so just give me 2 minutes to go and do my math.
Sure. Actually, you know what? Mirroring is going to be easier. It's okay, we got it here. The VGA adapter again. May I use this?
How we go fine, since I know I'm the version. Did you download it?
Yeah, I've got them all downloaded. Yeah, just like when I sat down here. Yes. Nothing. Oh, yes, I do. Yeah. Oh, okay. No, I didn't know that. You want to run things from yours? It's okay. Whichever. First of all, plug that in and see if it works. And I didn't see the other side of the clicker thing. Oh, it's in the clicker thing, isn't it? So that's your clicker thing. This goes, yeah, that goes to you. Okay, yes. Yes. Thank you, thank you, thank you. Once again, AMS has saved our presentation. Thank you. You can do it on this one. I don't. Whatever you're comfortable with. Okay? So so Stuart's first. We're working on it. Okay. You've got it right in front of you.
Okay. Okay, welcome everybody. We shall make a start. This is Dnssd. If you're expecting something else, you're in the wrong place. So, chairs are myself and Ralph Drums. As usual, we draw your attention to the notes well. If you haven't read it, please do. It's available on the IETF site as well. We have Tim Wyszynski has volunteered to take minutes. He's here. Good. Do we have someone that can just jabber relay?
And Tim, will you use the Etherpad? Okay, thank you.
Yeah, so feel free to load up the Etherpad and add any bits or correct typos on names or whatever if that's helpful. We do need a volunteer for Jabber relay. Oh, thank you very much. Main thing is just to raise questions that come in via Jabber. Okay, great, thank you. Usual slide that we include just pointing to the various bits of working group information, the charter, which we've updated the milestones for, more on that in a moment. The status page for drafts, which I'll show you in a moment. Meeting materials are all there, thanks to all the presenters for getting those in on time. And if you're not on the mail list and want to discuss the Dnssd stuff, I'd obviously recommend that you get there. In terms of the statuses of the documents, we're starting to look at as if we're in a good place. The label interops draft that we finalized at the last IETF meeting, that's now under AD evaluation and going through to the ISG, which is good. The main two documents that we're in the process of wrapping up are the hybrid proxy draft, or the discovery proxy draft as it's now called, plus DNS push, which is essentially part of that. So Stuart will just speak very briefly to those two shortly. We also have the ongoing work of the Dnssd privacy draft, plus the associated Dnssd pairing draft for devices, which Christian is going to update us on today. So that's where we are with the working group documents. So the goals for this session, hopefully we can wrap up the discovery proxy and DNS push work. DNS push is in working group last call already, and the discovery proxy we believe is ready to go through to the AD, but Stuart will just give us a quick update on that. We'll also have a little discussion about future work for Dnssd following on from the discovery proxy. You may remember the last IETF we discussed the idea of having an advertising proxy as well, so Stuart will talk a little bit about that and some of the other topics that he mentioned on the mail list a couple of weeks ago. As I said, we'll also progress the privacy work. That's a very important topic for us. So that's the overarching privacy draft by Christian and Daniel, and also the device pairing draft. We don't have a draft for it yet, but we'd very much like to progress work on a BCP on deploying Dnssd in an enterprise network. So Ralph spoke a little bit about that at the last meeting. Plus we have some text in a GitHub repository from Tom Pisateri, so if we can pull those bits together and maybe bring in another author or two to help with that, hopefully we can start that work going. It's a very important piece of work if we're going to encourage people to deploy this. Some clear guidance, a clear BCP would be very, very useful. We'll also have a quick chat on with Ted on the HomeNet naming and service discovery architecture. And then the final topic, hopefully we've got time, will be just to briefly talk about Dnssd in the IoT context.
Are we going to talk, Tom Terry, are we going to talk about the enterprise BCP later?
Yeah, so this is just what we're trying to achieve in this session. So agenda bashing, if you can, so quite a few topics on the agenda. You may need binoculars to, I don't think I can even read this on the laptop here. I think just a cut and paste. So obviously everyone's agreeing with the agenda because they can't read it. That's good. Trust us, it's a good agenda. And so it may have the same problem with the milestones, actually. So Ralph and I, as we agreed at the last meeting, we would review where we are with the milestones and then submit those. And Terry, as you may have seen from the mail to the list today, Terry's approved those. So that's our new formal milestones. The main thing was to update with the done status of the things we've actually done, which is good. And also to update on DNS push, the discovery proxy, and then the future work on the advertising proxy and the privacy work, plus the BCP. So those are all now in there on our milestone. We didn't need to recharter for that. Okay, so shall we get, oh, sorry, there's a question from Kerry.
Yeah, Carrie Lynn. I'm just curious, do we have something in the charter about IoT? Is it just that we're to document the challenges, or?
We have certainly mesh networking is in the charter as one of the environments in which our solutions should work. So I think it would fall under that. But
my question
I
is,
think the general question is, what considerations do we need in this working group for IoT type?
Yeah, are we charged with a solution, or with just documenting?
The idea is just to have 10 minutes at the end to talk about it and see what we think we want to do. If that does involve rechartering, we can discuss that. If it falls under what we're already doing, that's good. But yeah, it's open at the moment. Okay, so, oh yeah, sure, let's go for it. Well, it worked straight into mine, so I'd be optimistic. So while that fires up, I think we should also just congratulate our AD on turning up in a suit for today's session. That's,
Right, thank you.
right, over to Stuart.
I'm going to start with some quick updates on the documents and then some discussion of next steps. First update, DNS session signaling, which is not in this working group. It's a DNS op document. My co-authors are listed there. We updated this. This is about the mechanics of how you manage a long-lived DNS session. We previously got rid of the 12-byte header. I forget who wanted that, but we got a lot of pushback on that. So the standard 12-byte header is now back. I have no strong opinion either way, just looking for consensus. The sections are all empty. So the header is there, but the 4 counts must be 0. Another simplification, every request generates a response. Even if the response is empty, it makes it simpler if there aren't special cases in the protocol. And the major change in draft 02, which was submitted 2 weeks ago, is that the single timeout value got split into 2. I'll explain a little bit more what that's about. We realized that when we were talking about timeouts, we were talking about different things, and it was leading to confusion. And we realized there are actually 2 things. One is the idle timeout, which is when a client or a recursive resolver opens a TCP connection to another DNS server. It may decide to keep the connection open just speculatively on the off chance that it may have another operation to do. And this saves the overhead of doing another TCP 3-way handshake and doing the TLS session setup. But it consumes RAM because you're maintaining state. If you tear the connection down and set it up again, it's more CPU and more traffic, but you don't have the RAM overhead of idle connections. So the idle timeout lets the server manage its RAM load by telling clients either close the connection when you're done with it, or yeah, you can keep it open for 5 minutes, no big deal, I've got plenty of RAM. And of course that can be tuned dynamically. As the number of clients changes, the server can adjust the value it's giving them. The other value, which is totally independent, is the keep alive interval, which is if you have a long-lived operation, and this applies for things like push notifications, where you have an active operation at the server, even though you're not sending requests and responses on a regular basis. If the server crashes, or the NAT gateway times out your mapping, or the firewall times out your state, you may not be getting those notifications from the server, and you don't even know that. So the keep alive interval is saying, when you do have an active operation, This is the frequency that you should generate idle traffic to keep the connection warm. It lets the client know if the server's crashed and rebooted. It lets the server know if the client is still live, and it reminds the NAT gateways in the middle that they're both still live. Those two values can now be set independently. So that's the summary of what we updated 2 weeks ago. We've already had some discussion on the mailing list about that. These are the updates we're planning for draft 03. We're going to add text explicitly prohibiting name compression, because there seems to be a consensus that it's more trouble than it's worth in the modern world. Right now, the text says the 4 sections must be empty, and if they're not, they're silently ignored. There's been a push to say that should be an error, because even ignoring the sections involves some amount of record parsing to skip over them. So it's easier just to say if the counts are non-zero, that's an error. It doesn't close the connection, but it's an error for that specific message. Sarah wants to do a little bit of polish for readability on the document, and we have given ourselves a deadline of 2 weeks to do that so we can start the DNS last call. So that is the status update on the document we're all waiting for, session signaling. And I'll pause for a moment if we have any questions or feedback on that. And if not, I'll
just one from the chair here. Obviously, this is of importance for DNS push. Has there been any other expression of interest in other uses for this at all? Just curious.
Is Ray here? Well, it looks like Sarah's nodding. I think this was a document that Ray had in his mind for a long time and hadn't written. And when push came along, it reminded him that this needed to be done. The existing eDNS0 keep alive option is an eDNS0 extension, and the eDNS0 extensions are defined to be per message, not per session. So the existing keep alive option is kind of a square peg in a round hole. So this cleans up that. Okay. It facilitates push. It allows the server to indicate the idle timeout, which currently is not well specified. It kind of defaults to 30 seconds, but there's no good way of negotiating that you want more than that.
Okay. Sorry, the other use case is we'd like to have persistent connections for DNS over TLS using this mechanism.
Good.
So that's where most of the action has been. I will move on to push notifications. This is a quick update. Mostly it was for parity with the changes in the session signaling document. We have decided that every message has a response, even if it really doesn't need it. So the push draft was updated to agree with that. We fixed a mistake in the reconfirm operation that we simply forgot that when you do the reconfirm, as well as giving the record name, type, and class, you need to give the RData that you're disputing. So if a host address has 3 address records, but one of them isn't working, it's only that one address that you're disputing the validity of, not the whole RR set. That is fixed in draft 10. What I propose now is we wait for the session signaling last call to finish, and as soon as that looks like that document is stable, we'll do a working group last call here for the push document that depends on it. So with that, any comments or feedback on push notifications?
So we did start a working group last call last week on this, so we could extend that for another 2 weeks or whatever's necessary just to pick up any knock-ons from the session signaling last call. But
I'm sorry, I'd totally forgotten that.
I mean, we can always apply any updates. We can. I think that I don't think there's going to be any significant changes to this based on what you said from the session signaling update.
We hope not, but you never know with the IETF. So I agree with you. We should collect any comments we have in this group on push and do that update and cross our fingers and hope that nothing in session signaling rocks the apple cart too much.
So in which case, if people can read this draft and if they're supportive of it, just send an email to the list saying they support it progressing. So a working group last call isn't just about pointing out any issues that people see, it's also about showing expressions of positive support. So please indicate support if you agree with the document.
And this is the shortest status update at all. The hybrid document, we changed the name to discovery proxy to differentiate it from the advertising proxy. That is the only change in this document. Nothing in the session signaling the push changed the semantics of what's going on here. That this has been through working group last call, is ready for IESG review. Obviously, it doesn't make sense to give it an RFC number until the ones it depends on are also ready. But no reason the IESG can't get started taking a look at this.
Okay, so again, from the formality point of view, it's down to Ralph and I to write up Shepard's report for it and then pass that on to Terry to take forward.
Okay, now we get to the more interesting stuff. We have been discussing on the list and in person at the meetings next steps of useful things that need to be done. And speaking for myself, one of the things that's really been a motivator for this is there's an organization called Thread Group, which I recently started learning about and went to one of their meetings. They're building a mesh network using 6LoWPAN over the IEEE 822.15.4 radios. They're quarter megabit wireless radios, sort of the same speed and range as Bluetooth, similar battery consumption, so you can have a device that runs on a battery for years, which is very hard to do with Wi-Fi. Very useful for the upcoming Internet of Things, smart home, home automation, all of this thing that we've been hearing about for a long time is starting to get real. Google is doing work, Apple is doing HomeKit, Amazon has Alexa. This thing we've been talking about really seems to be getting real now. And what I really like about Thread is it's an IP network, whereas Bluetooth, which has similar performance characteristics, is a world unto its own that's not using the IP protocols that we're familiar with. So Thread has a lot of potential, but it's a mesh network. And that means multicast is really hard to do in an efficient, reliable way. But they still need service discovery, because the two things you need to do useful networking are discovery and data communication. Now, in the old days, discovery might have consisted of me yelling my IP address across the cubicle to you and you type it in, but you need the discovery step in some form, and you need unicast communication. Well, the mesh has unicast communication worked out, the discovery is still hazy. So that really motivated me to take another good look at the gaps we have here to provide useful discovery on these non-traditional networks that aren't a broadcast medium like Ethernet or even a Wi-Fi access point. So, first new work item for myself and maybe for the group is describing what I'm calling a discovery broker. And this is a pretty simple thing. From the client's point of view, it looks just like the discovery proxy that we've been talking about. You send it queries, it sends you answers. It will use push notifications to give you asynchronous change notifications. It looks just like a discovery proxy. The difference is it's not getting its answers from the local link using multicast queries. It's getting its answers by asking other servers over unicast. And that's why I call it a broker, because it's a middleman. And a couple of use cases like this are, you could have a client that wants to query 3 different links and aggregate the answers. And instead of the client having to open 3 TCP connections, it can open 1 connection to the discovery broker, which has those 3 connections on the back end on its behalf. So it's an efficiency optimization for the client that it doesn't have to open so many parallel connections. On the server side, it's an efficiency optimization because if you have a discovery proxy on your link, in the home, that might be perfectly fine. Or you have half a dozen phones, tablets, laptops, and they open TCP connections. So your discovery proxies are handling 5 or 10 connections from interested clients. But in an enterprise or at the IETF meeting, you might have 1,000 clients interested in discovering services. And if you don't want your Wi-Fi access point or your router to have to handle 1,000 connections, this is a way of moving that workload to some big iron hardware in the data center. you can have a discovery broker in the data center in a 19-inch rack mount that is some Xeon machine with lots of RAM. All the clients connect to it. It opens one connection to the actual discovery proxy physically co-located on the link. And that means that your discovery proxy now only has to serve one client. It serves the broker, and the broker serves everybody else. So I'm anticipating this will be a fairly short document because it really isn't defining any new protocol. It is the same protocol. To the clients, the broker looks like a proxy, and to the proxy on the link, the broker looks like a client. So it's just the same protocol being used in 2 steps. So that's the goal behind that.
Okay, so I think that from our point of view, we'd like to gauge the interest in the room in the various things you're putting forward. So should we do them as we go along and just see what's going on? So are there any questions or comments on that? I think it's well explained. Any concerns with this model as to any downsides that people can see? I mean, as Stuart says, it builds on what we've already got, so we don't need to define any new protocols as such. It's just an additional proxy for the proxy, if you like. Okay, can we have a hum in the room for people that would be supportive of work progressing on this topic? If you're in favour, hum. Okay. Anyone that's against? Okay, that was pretty clear. Thanks, Stuart.
Okay, thank you. I will try to get that draft written in the next few days. I know it's hard to ask people to have an opinion on something before it's written. I'm hoping that'll be probably like an 8-page draft. It should be fairly simple. Next item is the sleep proxy, which is actually not new. This is something Apple has been shipping for a long time. It's in all the airport base stations. If you turn on internet sharing on your iMac on your desk, then it will act as a sleep proxy. We just never documented it, and that's our oversight that I want to fix. I can tell you briefly how it works. When you take your device, let's take an example. You have your music library in iTunes on your Mac. Or let's say you've got a USB printer plugged in using printer sharing. But if your Mac is asleep, you can't use the printer. And if your Mac is awake 24 hours a day, then you're using lots of electricity. So the idea of the sleep proxy is when your Mac goes to sleep to save power, it transfers its state to some other device on the network. That might be your airport base station, your Wi-Fi access point. It might be something like an Apple TV, because an Apple TV takes 3 watts when it's awake, and an iMac takes 10 times that much. So it finds a lower power device on the network and says, be me while I'm gone and wake me up if somebody needs me. It does that using standard DNS update, RFC 2136, and it adds 2 things to it. One is that RFC 2136 didn't define garbage collection. It was really a human-to-machine protocol, at least that's the way I see it. You can use the NSUpdate command to add records and delete records, but once you've added a record, it stays there until somebody tells the server to delete it. And in a human interaction model, that makes sense. When you edit a file, you want it to stay edited. But when these things are done automatically by machines, it would be nice for it to be a bit more like a DHCP lease, where if your device crashes or runs out of power or goes away, then the system cleans itself up. So the first extension here is what we call DNS update leases, and it mimics DHCP. Whatever DHCP lifetime you got from the DHCP server, that is the lifetime you put on your DNS updates. So if you go away around the time that your address lease expires, the records claiming you have that address expire automatically as well. That's documented in that long expired internet draft. The other extension is a second eDNS0 option that's stuffed in the packet, and that tells the DNS server what your wake on LAN magic packet is to wake you up. And when that option is in the DNS update packet, what that tells the server is, if somebody wants me, this is how you wake me up. And if you take your Mac and you put it to sleep and you look with a packet sniffer, you will see, or at least with the older ones, you will see these packets go over the wire over UDP. Newer Macs often have a sleep proxy built in the Ethernet hardware, so they don't need this. But for devices that don't have an in-NIC proxy, they do this update over the wire. Do you have a question?
Yeah, Barbara Stark. So I've kind of worked on this sort of thing in other organizations, and one thing that we came across was there's more than one magic packet that devices have. Frequently they'll have, this one wakes me to my network interfaces are on state, this one wakes me to my entire operating system is on state, this one wakes me to a state where these applications are actually up and running state. And sometimes there's also a password associated with it. Anyway, so this may be too simplistic.
Thank you. This document here is about 10 years old. I think it includes some of what you said, but not everything. It does include the option to specify the password, although of course this is all sent on the clear and in the net, in the clear on the network. So calling it a password is it's questionable how much strength is in that, but it does support that. In terms of having different levels of wakefulness, I was not aware of that. I could imagine that when the machine goes to sleep, in the Dnssd option, it says, this is the magic packet I want you to use to wake me up, and it would put the appropriate one in. If we're going to finer grain that I only want to wake up the SSH daemon, or the printer sharing daemon, or the file server daemon, then that is something that might be harder to do. But the reason I'm taking this out of mothballs is sort of ironically, it's not that relevant for Macs anymore, because these days all the Ethernet and the Wi-Fi hardware has a proxy built in. But with Internet of Things, 6LoWPAN, CoA, Thread devices that don't have a proxy built in, it might, this feature that was sort of on its decline might have a new life, maybe not in exactly the same form, which is why I thought it was worth reviving this draft to have exactly this kind of discussion about how this might be useful in today's world.
And I think it would, and I'd actually enjoy working with you on it, because one thing I'd like to do is there is a UPnP sleep proxy service defined, and I'd like to see if maybe we can harmonize and not be divergent.
Okay, thank you.
Hi, this is Andrew Sullivan. So I like this work, and I remember reading the owner option again, like 10 years ago, right? So I think it's useful work. I guess the one question that I would have for the room is whether this is work that is going to be most effectively done here, for exactly the reason that you say, that the use cases seem to be a number of cases. I'm just a little nervous that we might not attract the right people to make sure that, for instance, the magic packets that they have and so on. So as long as we're convinced that we get them here, so that we don't work on something that turns out to be something that is not the way that they're going to do it, I'm happy with it. But
I had no idea this topic would attract so much interest.
You pushed a button, Stuart.
Yeah, I just woke up. I don't know what this is about.
Let me answer Andrew's point. I think these are good questions always at the IETF, that we want to make sure we have the right audience. The reason I think that this is the right working group, if it was HomeNet, I would say, yeah, this is not really a HomeNet thing. But I see the role of this working group as providing the service discovery services that other parts of the IETF need to hopefully limit the reinvention that goes on, and say we will make it our life's goal to make an awesome service discovery mechanism that meets all of your needs.
Ted Lemon. So on that exact note, I'm not convinced that this is the right place to start on that project. And the reason I say that is because looking at the various things you've listed there, the only one that I think is probably fine as is the Wake on LAN magic packet. The garbage collection stuff is neat, but I think it might be worth doing a little bit more of the lifetime analysis, an analysis of what the lifetime of the stuff the stuff that a service adds to the DNS or publishes, however it publishes it, ought to be. Because it's not clear to me necessarily that the fact that a device is powered off and not updating the DNS means that you should relinquish that name, just as an example. It may not be that we can cover all possible use cases, but I think it's worth at least talking about them.
Do you have a suggestion for another working group or another venue that would be good for this?
I'm okay with doing that part. I'm okay with doing here. What I was agreeing with was that there needs to be a little bit more high-level thinking about this.
Okay.
Eric, Eric, not Mike. So, yeah, I think that this is something that, as far as I can tell, makes sense doing in this working group. I came here to ask about the other parts that are part of the sleep proxy. Like, I know there's some ECMA spec that talks about proxying ARP and neighbor discovery and other pieces. So those are things that we don't think we will need because this is sufficient. You're redirecting in the DNS, and that's takes care of it.
Thank you for raising that point. And if I'd worked a bit hard and got the drafts done, that would be written down. So the reason I said at the bottom, time to document it, is exactly what you said. And you're right, I glossed over the details in this one slide. The sleep proxy does 3 or 4 things. It answers the multicast DNS queries on behalf of the sleeping device. It answers ARP queries on behalf of the sleeping device. It answers neighbor discovery queries on behalf of the sleeping device. When it gets an inbound packet, be that a UDP packet or a TCP SYN or a TCP data packet, it then inspects the contents of that packet to determine whether it should wake the client up. And if it does, then it uses the data in that owner option to generate the magic packet. And I kind of glossed over some details there when I said it inspects the packet. So for example, if there's a TCP SYN to a port which is known to be open because it appears in an SRV record advertising that there's something listening on that port, that's a good reason to wake up the device. If you get a SYN to a port that's not even listening, then you don't need to wake up the device for that. And that logic is exactly what needs to be written down in the draft. At least, if nothing else, just to document it for the benefit of the community.
Yeah, I mean, it would make sense to capture all of that in one place where you can at least see all the pieces, right? And then run those pieces by the interior working group person.
Yeah,
sure.
That makes sense. And yeah, I think what Eric just said about presenting it maybe in interior as well to get the wider view is a good one. We'll cut the line at Christian, so carry on.
So Stuart, I think this is a good work, and you mentioned a few times about 6LoWPAN and thread. So I would assume the scope of the work would be the Internet of Things of devices that are a little bit larger, like Alexa and maybe gateways, and as well as smaller capacity devices like light bulbs, sensors. Yes. So I think that's something is currently missing in the solution of 6LoWPAN. You know, we have, but we don't know how to do the service discovery in a standard way. So I was thinking if you need any collaboration or help, I think I'm a co-chair in 6Low working group, so we can help you out with that.
Thanks for the offer.
Reviews and all that.
Thank you.
Christian Wittema. I'd like to push for actually doing this documentation work. And I come from personal experience. I was testing a Dnssd implementation. And what you do with that, and you test against various devices like Macs or iPhones. And you find these weird eDNS options. So what the heck is that? And I found the old draft explaining what it was supposed to be, except that the old draft doesn't quite describe exactly what is in the packet. It's slightly different. So just for the sanity of having stuff described, I think it's a really good idea.
Yeah, I think that was Stuart's driver as well for this. Plus, so you're saying there seem to be more devices that can benefit from this now. So
Yeah, I didn't tell the full story. The thread group was part of my motivation. The emails back and forth with Christian were the other part of the motivation, but it's time to document this.
Okay, it sounds like there's generally positive support here. It's a matter of whether this is the right place. It sounds like most people are saying that it is, perhaps, but also presenting it into area where it can get the wider review. So, okay, so I think we can, from the comments said, we can agree to take this on. So, what's next on the menu?
Next is the advertising proxy. And this is why we renamed the other thing to discovery proxy, to make it clear. And it's the conceptual mirror image. A discovery proxy lets a remote client that's not physically attached to the link have a device on the link, be a proxy on its behalf. And I describe it as being analogous to making a phone call. I'm not at home, but I can call up and ask my daughter, hey, can you look in the printer menu and see if the printer's showing up? And I can ask somebody over the phone to do a discovery on my behalf and then read back the results they see over the phone. And that's analogous to this, is I make a TCP connection and ask this guy to do a discovery on my behalf and tell me what it finds. So that's a discovery proxy. And the natural counterpart to that is an advertising proxy. And again, this motivation for this, the insight for this, or the inspiration came out of thinking about the mesh networks. You have a device on the mesh network. It's not on your home LAN. It's not on what we might think as the core network, the Ethernet, or the Wi-Fi segment where multicast and broadcast work. It's 3 hops away in the mesh, and it can't directly participate on that. But it might have services that are useful and are reachable by unicast. So an advertising proxy would let it reach out to some proxy, which might well be your access point, is a logical place. The same place your DHCP server lives is where this would live. It reaches out to that proxy and says, I'm not on the multicast network, but can you advertise the service on my behalf? And this is my IP address, this is the port I'm listing on, this is the service type. And then from the point of view of clients, they discover it, they connect to it, they get a connection, and the clients don't even need to know they're talking to something 3 hops away on the mesh. A lot of these things, if I drew a Venn diagram, are very much overlapping. This is a lot like the sleep proxy, but without the magic packet, because the device is actually not going to sleep, but it is asking something else to act on its behalf and advertise. It probably would still want the garbage collection, because in the event that you unplug it and take it away, you don't want garbage to accumulate without limit. You want something to clean that up. And we had some discussion earlier about we need to think about the right way to do that garbage collection. But I think we do need some kind of garbage collection, because otherwise we get into a situation where you've got to power cycle your gateway to clear out the old stale state. So that is hopefully another small draft.
Ted Lemon again. It occurred to me, I forgot to ask this when I was up with Mike last time, but since you're talking about DNS update again, I'll ask it now. I tried to game out a DNS update process for Dnssd, and it was a lot of exchanges. Like it was not a simple thing. It sounds like it seems simple to you, so I'm wondering what the disconnect is.
Yes, it sounds like we should talk more. Unless I'm missing something, with the current code running the sleep proxy, which I can talk about because it's shipping, so I have confidence that our thinking is same there. First, there's a discovery, recursively multicast DNS is due to discover the things that are proxies, and then having found one and picked one, it's a simple 2-packet UDP exchange. You send a DNS update with all the records in, and you get back a reply that says rcode 0, and you say, great, I can go to sleep now because I've handed off my records. So
I'm going to interrupt and ask you guys to take it to the mailing list, because we're actually running a little late.
Okay.
Thanks.
Happy to do that.
Okay, and just within the room, just to check there's consensus on taking this forward. Can we have a hum for those that support progressing this work? And is there anyone against that? Okay, so thank you, Stuart.
Thanks, Tim. So I think this is the last one before we get to the the interesting diagram. Many people have pointed out that when you have multiple links in the house, having things with the same name appear in multiple places is confusing. And I agree. This is just one slide to kick off a discussion of how we might do that. I proposed on the mailing list this idea of having bilateral arrangements that if you've got two links where you don't want overlapping names, you have a discovery proxy on each link, and you configure them. And when I say you, either the administrator does, or in the HomeNet case, it's auto-configured out of the box. The two proxies talk to each other, and every time a new service says, I want to use the following name, they query their counterpart at the other end and just check in with them and say, something wants to use this name, is that okay? Is there a conflict? I think Pierre or somebody pointed out on the list that, maybe it wasn't Pierre, if you have multiple links, this is an n-squared problem that you have a lot of bilateral connections. That's true, but if n is small, it may not be a big deal. So in the interest of time, let's not try to solve this right now, but this is just to put some thoughts in people's heads so we can try to figure this out.
Yeah, I think, well, Ted talked about that. I think you put some ideas forward at the last IETF, so it's clearly in a few people's minds, and it is an important issue, but there's no obvious, easy answer. I think there needs a bit of thinking about it. So, but it's good to have it raised again. Thank you.
And then the final inspiration I got from attending the thread group meeting was there's a lot of stuff going on here that many of us in this room do understand, but I feel like it's my failing. I've not done a great job communicating it. So I decided that we really need a roadmap document that shows how all this fits together. And I tried to make a diagram to explain that. The most important concept is that IANA maintains a list of service types. And I mentioned this before I talk about DNS or multicast DNS or anything else. The most important thing is that we have a vocabulary. When a server offers a service, we need some namespace of identifiers that say what service is what, so that when a client says, I'm looking for service foo, the server has got to use the same vocabulary to say, I offer service foo, in order for that rendezvous to happen. So that IANA registry of service types is really the linchpin of all of this. That feeds into DNS-based service discovery, but it also feeds into any other kind of service discovery. You can do service discovery over 822.11, pre-association, gas frames. You can invent lots of service discovery mechanisms that aren't using IP packets, aren't using DNS format packets, but if they use that same namespace of service types, then a client application that's searching for service X can find servers that offer that service X, regardless of what discovery protocol is used. Under the umbrella of DNS service discovery, we can do that with multicast. On an unconfigured residential network, we can do that by unicast like we do at the IETF. Of course, both multicast and unicast DNS give us naming as well as service discovery, which is a nice code reuse. Multicast DNS runs over UDP and over IP multicast. Where the interesting action is now, and in coming months and years, is on the unicast side. We've talked a little bit about doing DNS updates to push data into the namespace. The discovery proxy is another way to conceptually import data into the tree of the unicast DNS namespace. The discovery proxy also benefits from doing long-lived queries to give asynchronous change notifications to the client without polling. And of course, we're working now on doing that using push notifications over TCP, which is a lot better than rolling our own UDP-based protocol. We've talked about introducing this discovery broker, which is an intermediate step between the clients and the little discovery proxies on the links. We've talked about having an advertising proxy, which is another way that data gets into the namespace. And a sleep proxy, which is kind of like an advertising proxy plus magic packet. The update lease is a useful addendum to DNS Update because it provides the automatic cleanup. And another component of this overall technology is some kind of default domain name with special properties so that vendors can ship products out of the box. And I'm calling it .home_tld as a placeholder here. The actual string is to be Terry's holding his face in his hands.
I didn't see when he came in. I didn't see when he came in. I should have frisked him for the stick he was going to poke somebody with.
I will note that asynchronous notification is an important part of this. Multicast DNS inherently has change notifications. DNS LLQs and push notifications are how we provide that capability for unicast DNS. And then the final slide, because I put a bunch of words on here and we actually need documents and RFC numbers to refer to. So this is the collection of documents. And now I need to turn that into 72-column ASCII art to put it in an RFC.
I think.
I do want to say in my defense, because this looks like a very scary, complicated thing, and that worried me when I was preparing it. I think that what we've done is we've divided the technologies into little small building bricks, and different scenarios may need different of those bricks. It's not likely that you will need all of this in the same place. But a consequence of that is it does make the chart look kind of complicated at first glance.
Carrie Lynn. So Stuart, something that you and I have talked about in the past, but is not reflected here, is the potential to do a finer grained discovery than is currently possible. And I have specifically in mind the fact that REST seems to be, becoming the dominant architectural paradigm for many applications. I'm not really sure what the difference is between an application and a service, so there's a little bit of terminology leveling that we'll have to do with other groups, especially the IoT folks. But I have a proposal that I have at least started that does allow for multiple services running on the same IP and port, specifically port 80 or whatever, and having URIs to identify the entry points for APIs. That's what.
Yeah, thanks, Kerry.
We'll cut the line at Andrew.
But I don't know whether that's within our current charter, because M2M was specifically excluded when we first chartered this organization, so hopefully it's in the
Terry Manderson, no hats. I love this. I think it's fantastic. New RFC format supports SVG. Thank you.
Does it support animated keynote?
My name is Andrew Sullivan, and I was standing back there trying to figure out what was making me a little concerned here. What I realized is that we've got 1034 and 1035 on there a couple of times, and it strikes me that here and in a couple of other working groups over time, we have gradually formalized a number of ways to use split horizon DNS without actually saying those words. And this seems to be another example, particularly here and in the HomeNet naming architecture, where we're definitely doing that. We're definitely trying to use sort of site local scope. Well, that's what the TLD thing is over there, right?
To make sure we're talking about the same thing, I agree with you. Like this little bit here about the out-of-the-box auto-configuring at home is split horizon. But I would view that the rest of it
doesn't have to be.
Okay, then we're in agreement.
So one possibility is we just throw that piece away and we don't have to worry about it but I feel like there's some sort of ticking time bomb around the IETF where people keep coming up with these split horizon things without actually formalizing it. And maybe a service that we could do in this case is literally to add that to the scope here and sort of say, this is really how this kind of split horizon is going to work or something like that. I see Ralph looks like he's going to be airsick, so maybe I'm wrong. And I don't know whether it's a good idea, but it seems to me while we're making charts of many, many documents we've got to work on, it could be one more.
Thank you.
Very, very briefly, Andrew, I understand the point you're making, and while I might disagree that we've gotten there yet, I think we're very close to getting there in some other circumstances that we could talk about at a different time. Looking at that in the big picture, I wonder if DNSOP might be a better place to do that as sort of a general place to do it where we have the right expertise as opposed to us who are mere dilettantes in DNS.
Okay, great. So over to Christian. I'm not sure which is the right clicker now. It's probably that one.
Yeah.
Oh, something was.
So yeah, we have presented already at a couple of meetings the work we are starting on DNS privacy, and we made a bunch of progress on DNS privacy and on a companion draft based on implementation attempts and reviews. So basically, if you read the previous draft, what we have come up with the 0.1 version there is a bunch of simplifications that largely result from the work on implementations and surfaced a couple of API issues that will require maybe some discussion. The first simplification is on the work of instance name. So what we want to do for private discovery is send random numbers instead of sending actual names to discover a private discovery service and then set up a TLS connection to that private discovery service and do things privately without exposing them. So I'm looking at the discovery of this private discovery service. The first version we had, is this something you want to look at? Yeah. The first version you had was, I was trying to pack a number of instances in a single frame, in a single big name. And after more implementation experience, it's much simpler to formalize this private name as just the concatenation of the nonce and a proof, where the proof is the hash of the nonce with a secret. And it turns out that we don't need to do this kind of early optimization here, because if we do use name compression in the results, then we can fit a very large number of records in a single message. So having a very simple instance name there gives us a better way. The second part of the work, which is something I already presented, we discussed briefly as an hypothesis in Yokohama, I believe, is to standardize on a nonce size of 24 bits. And on 24 bits, that would be effectively the 24 high order bit of a 32-bit Unix time. So that you get effectively something that changes about every 5 minutes, every 4 minutes and 16 seconds exactly. And that's a compromise. It's a compromise between having nonce that change often so that you can get protections against replay attacks, and having nonce that change too fast, which will require a lot of computation. The replay attack happens when you take something in one context and the person has moved, I mean, the device has moved, and you replay the string in another context. With that, I mean, if the device cannot, basically attackers only have a very short time to play that replay attack. It's less potent. The one issue with that trade-off, it's a very nice trade-off for a number of reasons. But there is one issue, which is what happens if instead of having a multicast deployment, you have a server-based deployment. And especially if your server-based deployment wants to do something like DNSSEC. Because in that case, the server would have to recompute zones every and signatures every 4 minutes. And that might not be the right trade-off. The next engineering decision we did was to look at the size of the proof. So the proof is always defined as the first bytes of a hash. So effectively, we assume that devices that want to recognize, to discover each other privately, have shared a key using, for example, the pairing protocol, have shared a symmetric key. If they can do that, they can compute, If they can do that, they can compute a hash of the nonce and the pairing key, take the first byte, and get an instance name. And basically, they can both compute that. And because they can both compute that, they can find each other. Now, again, there's a trade-off. The proof shall be long enough to prevent collisions. But it shall be short enough that the instance name that you generate don't create a lot of load and very long messages. So we went in great details about that. It turns out that to be long enough, you need probably at least 32 bits, given the number of devices on the network, birthday paradox, and these kind of things. And it turns out also that if you use base 64, 32 bits and 48 bits are encoded with exactly the same number of characters. So in the draft, we propose to use basically a name which is composed of a 24-bit nonce, a 48-bit proof, and encodes as 12 base 64 characters. And that gives us nice properties in terms of message size and query size and things like that. So, I'm getting confused with this story. The next thing we did, which was in fact something that my co-author Daniel Kaiser did within his thesis, is say, hey, if both client and server can predict the name, then we don't necessarily need to do a full Dnssd discovery. Because you know you can guess the instance name that you want. So if you can guess the instance name that you want, if a client wants to find a server, that client can compose the instance name that it believes the server will use, and just do a request for that instance name, look for the SRV record, and find whether the server is present or not. And in fact, if the client has a number of peers, it can repeat that a number of times, for composing one instance name for each of its peers. But the good thing is that using the Dnssd format, the client can pack multiple queries in a single message. And doing that, it can query for all its peers in a single message. So we get this very efficient mode in which the client predicts the random name that all its peers might be using. There may be like 2,000 of them, for which there are 2,000 different pairing keys, so 2,000 different address names, instance names. I just send a query, it just sends 2,000 queries in a single message. In fact, if you use name compression, you can go to something like 70 queries with what we have. So it gets very, very efficient. The answers can be sent in unicast, because after all, there's only one peer that can use the particular answer. So, Daniel Kaiser in his thesis explained why this is the most preferred solution. And then, so that's for the engineering. Basically, what from the engineering part, we are pretty happy with what we have, and we believe that we will go for there. We need a little bit more experience maybe, but that's about it. On the API, we were concerned with doing the right API for finding something in the private domain. And suppose that Alice wants to find someone, she's going to use the existing API to find it. And she has to express in the API that what she wants to find is not just a particular service like this example service, but she has to find it in a private way. So what Daniel and I decided to do is to put the private way, this private keyword, just before the scope of the query. So you would be looking for private.local or private.home or something like that. And that would create a different behavior that instead of immediately sending a Dnssd request for this example.tcp.local, you would send a request for the private discovery service, either using directed discovery as we saw before, or using classic Dnssd discovery with a full discovery. With that, you would discover all the instances of this private discovery service, and the resolver will set a set of TLS connection to its peer, to the peer that are present on the network, and then request for this example service. And of course, the connection can be cached, it can be maintained for some time, etc. So that's basically where we are in terms of API design. And and that's about it. I mean, basically, we have an implementation underway. Daniel did a couple of prototype implementation for his thesis, but he doesn't present them as anything that people can use, so he doesn't want to brag too much about it. We expect to get some discussion, but we are pretty much engaged. I believe we are very near ready for this one.
Okay. Are there any comments from the room? I guess the question is whether you think you're going to learn any more from the further implementations that might lead to changes, or are you happy that...
We want to verify that basically the connection to the private discovery server is a TLS connection that is supposed to be protected by some method that can be verified with a pre-shared key. And the pre-shared method will be a DHPSK or one of those variations. We want to verify that we have no problem granting that. This is the last part. Apart from that, everything else is pretty straightforward.
Okay, so I think we are very close to doing the working group last call. Ralph, you? Okay, so we'll discuss that between us afterwards and launch the call in due course.
Okay. So then we
I think the other thing we can do, we did do an early security area review. It might be worth popping the... yes. Good point. Just coming up now. There we go.
So the discovery service that we suggest here, the private discovery, relies on having pre-shared keys between paired devices. And we actually do not use the public key technology for a variety of reasons. You could not do those tricks with public keys. You have to use symmetric key technology. So to do that, you have to have a way to install those pre-shared keys. And indeed, we could rely on manual keying and things like that, but that would not be good. So we have specified this first pairing draft, the 00 draft, And we published it just in time for SEO. I don't think that we had the time to present it at SEO. But
I don't. No, I think it might have
we
been.
presented the first version in Yokohama, and it was, SEO was a minority.
Okay, yeah, I think it might have been that either Ted or I presented it briefly there.
Anyhow, since that, the two big changes were first a review. I mean, asked us to do to ask for an early security review, and Steve Kent was kind enough to do that, and he did a very thorough review. It was very nice, and his review at a high level was that the structure. I mean, the security part was good, but there were lots of stuff in the presentation, and we'll go through that feedback. We also, in the same vein as the discovery, I mean, working on the implementation with some simplifications and also some precisions. So one of the feedback that Steve gave us is that in the initial text, we add some kind of a bifurcated thinking about QR codes. And Steve and others observed that there are a number of agreement schemes that use QR codes because it's very nice. Specifically, in one scenario that we often use very often is when you want to synchronize a laptop and a cell phone or two cell phones. Because the QR code can be read by the camera, can be processed immediately. So we rewrote that part to give a complete example of how QR codes would work. The pairing has three phases. It's the discovery phase in which the two devices that want to pair discover each other. Then there is an agreement phase in which they negotiate a secret. And there is an authentication phase in which they verify that there is not a man in the middle that has been messing around with the secret. The way we use QR code is that normally discovery is done using Dnssd, discovering the pairing service. But with the QR code, what you can do, you can read the QR code and you immediately get effectively the content of the SRV records that will be used for the discovery. And that allows you to go very fast without asking the user to go pick a pairing device in the menu. So that gets faster. And of course, if you don't have the QR code capability, then you do use Dnssd. Then the agreement has not changed. It's using an anonymous agreement to negotiate the keying. And the authentication, the mechanic of the protocol has not changed. It's used the short authentication strings algorithm and saying, and the whole thing about sending first a hash of a nonce and then sending the second nonce, etc., and counting, and displaying the same string on both devices. What the QR code gives us there is that instead of just displaying the string, you can display the string and display a QR code containing the string, which allows the pairing device to just scan the QR code and verify it's the same as yours. And that way you get QR codes which are just used as an input device, but give you the right user interface. Simplification. One, there was a lot of speculative language in the first draft because we are thinking of various things we could do, we might do, etc. So we went through that and we removed a lot of it. In particular, we removed a lot of something we had been thinking about, which was to have two different mechanisms to establish pairing between devices of the same user and devices of two different users. So, well, we might do that eventually, but for now, let's see that there are devices and we just pair them. The other thing that we did was a suggestion by Steve. One of his feedback was to say, hey, you must have a mandatory to implement cyber threat. And we are using TS 1.2 in the spec. It was telling us, well, that's the right thing to do. You should not base your work on prototypes. And basically, it suggests that we have to implement TLS, DPLman Anonymous with AES 256, CDC, SHA-256 256 as a standard mandatory to implement. So that we can basically rely on that to get effectively a shared secret on zero configuration. And the other suggestion that Steve Kent did, so a big suggestion, is that he really would like to see that draft split in two. His feedback was that what we wrote, we read like a research paper, which was perfectly fine when you're doing a PhD, but the specification part should be much more directive. And so he suggested that we split what we have between the research part, which explains all your hypotheses and why we do stuff, and the specification part, which says, hey, this is what you do, you must do this, you shall do that. That's, again, something that I'd like to get into.
It's an open question, yeah. So who in the room has read the draft? Okay. Is that Mark over there? So have you got any view on that? So it looks like we don't, I think we need to encourage more people, therefore, to read the draft. I think I'm personally quite happy with the way it reads. I understand Steve's point. I guess one thing you could do is to put the sort of motivational bit in an appendix maybe and keep it in the same thing, but I would be tempted to keep it as it is personally. Nobody have any view, Ralph?
Yeah, I like the idea of putting it into an appendix if we can. How would that be a lot of work, Christian, to restructure it that way, or? But it's not. Well,
No, it's not obviously.
It's just moving into text. I quite like having the motivation and the text at the start. Dave?
Dave here, I was going to say the same thing as Tim. I like having them be in the same document. I mean, I like documents that put the design rationale in the same document as the actual formal specification. Putting it into appendix sounds fine.
I mean, we've also kind of split this work once. We don't want it to keep splitting ad infinitum, and the RFC editor would not be happy.
Okay, so that was my next step. Basically, I was asking you to split the document question. So your suggestion is that we do not split it right now?
Do not, yeah.
Okay. And we want to finish the implementation. In particular, we want to make sure that it's easy to do this TLS anon connection, anonymous. It's not supported by every TLS suite. We want to verify that. I know it's in theory supported by OpenSSL, but you know, it's theory, practice, etc. So I'd like to have to practice that. And also the other verify that we rely on a key extractor to make sure that we can extract the key that was negotiated by TLS and use it in the application.
Okay.
So we have to verify that it's available.
Okay. Again, I think we could move to working group last call, but the exact timing of it we can discuss offline.
I would prefer to get another review.
Yeah.
Based on the conflict, I mean, adding two in the negotiation.
Yeah. Okay. I guess I could just ask if there are one or two people in the room that would volunteer to read the current version and give some feedback. Great, Stuart and Ted. Okay, we've got 3 volunteers. Note those down, Ralph. Get the photos of the hands being raised. Great, thank you. Thank you, Christian, that's excellent. Okay, so where are we? Yeah, so the next item on the agenda was just to discuss the idea of having a BCP in terms of deploying this stuff. or deploying Dnssd solutions, the discovery proxy, and perhaps some of the other components that Stuart has described in an enterprise environment. And I think that would be a particularly useful thing for people that are coming to this fresh and wanting to deploy it without having to dive into all the RFCs. And I think Ralph gave a really good presentation an IETF or two ago showing some of the ways you would delegate the zones out, etc. Tom's got in that GitHub an RFC style document with some configuration advice as well. So we've got the starting blocks of something. Are there any other comments on that? I think it would be a good thing to do. It's a matter of people's time and to pull it together.
Tom Pusateri, Ralph and I volunteered to write this BCP a few IETFs ago, and I've been thinking about it, and every time I go to try and write something, I feel like we don't have enough information. Like, we don't have deployment, and we need some deployment experience to write a BCP. And there's we need a larger scale deployment to work out the kinks. And that's where I'm stuck.
Okay. Well, in which case it may well be that we're starting from an informational point of view with the theory of how you would deploy it. At least it's a guide then that could revise and become a BCP at a later date through experience.
Rand Atkinson. I'm sympathetic to Tom's perspective that a BCP might be premature, but I strongly believe that an enterprise-oriented informational document that is not a cookbook, but does talk about how all the pieces fit together in an enterprise environment with multiple sites and large buildings and so forth. And Ralph and I have had a conversation about that, and I'm happy to help with use case on that piece of it in conjunction with Ralph and Tom, if that sounds sensible.
And I'll interject myself for a second. Something that Rand implied there is just this, starting off with a description of the building blocks themselves to talk about here are the pieces that you have, here are the tools that you have to work with, and then Tom, I've looked at your document very quickly to say here's one way of putting things together, and then taking Rand's example, the next step is here's in a larger example, here's how you can put things, here's how you can put those building blocks together, and here are the pieces you need to put into place to get the larger example to work.
Tom Pusateri again. The document that I have is more about, here's the knobs that you might want to have on a hybrid proxy or a discovery proxy. It's not really about a deployment as much. So it's just like, I figured these configuration knobs are useful. I wanted to document them. So
definitely, yeah. But what you're saying is you don't have the experience of deploying with the various settings on the knobs, so to speak.
Yeah, what I would really like is for some people who want to deploy this in a test way to make themselves known, and we can have some code and we can throw it out there and play with it. That's what I would really like.
Well, I'm aware of, in my context of university network, people that are willing to test and deploy this, but A, they need code, and B, they need guidance. So we need to pull those things together. Dan?
Dan, I was just going to say, I think this kind of document is useful, and I agree with what Tom's saying, that maybe just don't use BCP, deployment guidance, deployment observations, things like that. We've done documents like that before, where we've talked about, here are observations about how to, in the current state, how to do that. And then later it can be the form for something that evolves into a BCP.
Okay. Yeah, I think there's a very clear message to start informational. So thanks to Rand for offering some parts. We've got obviously Tom and Ralph. Maybe one or two authors might be welcome as well. But if we can get something kick-started, as Tom said, it's difficult. The hardest thing is to get it started. But if we can get something out there, and that might attract more authors to help along. Great. Okay. Well, thank you. Next up is Ted. If I can find the slide deck. This is the one. Bright orange. Woo. So it's you and then Inez, yes, and I think there's a little bit of overlap with the end of yours and Inez's as well. So yeah, we've got just over 35 minutes for you for the last two.
So I'm here to talk about display color.
Oh.
Sorry, I didn't realize
it looked fine on my screen. I couldn't see that screen because you were in the way. Oh God, what's happened here? It's doing some funny mirroring thing.
I think you
Now how do I get to it? It's gone.
What you really need to do is turn on the mirror.
Ooh, but I can't see it.
Can you go to the next slide? Yes.
Yes.
So I called this talk Dnssd directions because these are directions that I want to go, not necessarily because the directions that the working group wants to go. And you will notice a really tremendous amount of overlap between this presentation and what Stuart did, although I don't have a nice little animated diagram. The topics that I want to talk about are Dnssd on the home net, the way that you might be able to use Dnssd discovery proxy to produce DNS responses out on the internet, the potential relationship between Dnssd and core resource directory, and the general problem of registration. Next slide. So Dnssd on the home net. I've written a new document called the Simple Dnssd, the Simple Naming and Service Discovery Architecture document. I previously worked on a document that was not called the Complex Home Net Naming and Service Discovery document. Danny Migo, by the way, is working with me on the simple document. The other one was entirely my fault. This is a choice that the that the home net working group needs to make, whether they're going to do something fancy or whether they're going to do something simple. And there seems to be pretty split sentiments on that. If they decide to do something complicated, you're probably going to hear a lot from us. Next slide. So I'll talk a little bit about the document that I just produced for those who weren't in the HomeNet meeting. It conceptually splits the DNS, or actually it really splits the Dnssd hybrid proxy into two parts. Somewhat analogous to what Stuart presented, but not exactly the same. So one of those is a proxy that just does queries on the local wire and never talks to clients at all.
Can you just rename, what are you naming?
Huh?
What are you naming?
Naming and service discovery.
Yes, what are you naming on this slide? HomeNet is naming what?
Do you know what DNS service discovery is normally used for? Okay, so that sort of thing, basically.
Services.
Yeah, yeah. I mean, I say naming and service discovery because, in principle, you could just name your host, and but hosts generally produce services, so, yeah. So anyway, so the relay proxy is not user visible, but it does speak DNS protocol to the aggregator, which is the querying proxy. Query proxy is what hosts actually talk to when they're trying to discover services, and it speaks DNS to hosts. It supports DNS push for hosts, and it speaks DNS to relay proxy, the DNS protocol. That's what I mean by DNS to relay proxies. It aggregates responses and does all of the name rewriting you expect it to do. The same. So basically, it's this thing together acts as a discovery proxy. Next slide. It's not stateful. You can't do queries from the internet. And the link names that the discovery proxy specifies are machine-generated, ugly, and make no sense because we have no way to give them meaningful names because the user probably doesn't even know what a link is. Yes.
It works. Or maybe not.
Sorry.
You want a next slide again?
Yeah. Next slide. No worries. I didn't actually talk about the name conflicts thing, but thankfully Stuart did. So we need to figure out some clean way to deal with name conflicts. And actually, I think Stuart talked enough about that that I don't need to say anything more about it. Stuart and I really need to talk. We haven't since Buenos Aires, I think. This is things HomeNet needs to decide. Are we happy with the stateless approach? How are we going to deal with name conflicts? And is there a long-term way to fix up some of the problems with registration? And this last item is the one that I think is probably the place where Stuart and I disagree a little bit. But let's see, next slide. When doing, so now we're to the topic of suppose you're doing Dnssd with the discovery proxy, which is, by the way, Dnssd is actually RFC 6763, and I've been liberally saying Dnssd and meaning discovery proxy throughout this slide deck. So I'm not talking about 6763 here. I'm talking about discovery proxy. So the issue, so to get Dnssd into the DNS, to get services on your local network into the DNS, there are a couple of models. One is to have the discovery proxy itself be the name server and be completely stateless. So queries come in from the internet, your discovery proxy goes and does a query on the wire, gets the answer, sends it back to you. The next way to do it is to do some caching, so the discovery proxy isn't constantly doing queries on the wire. Now, of course, there's some built-in caching in a discovery proxy anyway, but I'm talking about a sort of a centralized coherent cache that just caches the information. It doesn't try to construct a DNS zone or anything like that. And then another option is to publish real DNS zones using the information that we discover from the network. It's not clear that there's actually a difference between caching and publishing a real DNS zone other than maybe a little bit of extra bookkeeping. But that's an interesting question, and I'm not sure what the answer to that is. There's a lot of questions in this document. I have not answered many of these questions. They're more like things that I'm interested in learning about than they are answers. So one of the big questions is, could we actually do DNSSEC if we didn't build a real DNS zone? And I don't know the answer to that question. Problem with doing completely stateless is that it requires multicast on the wire for every query. And so I'm seeing now that I made the assumption that you would understand that there needs to be either stateless queries that happen kind of whenever a query comes in or after a cache entry is expired, versus having services on the wire actually do a unicast registration, which is something that Stuart talked about a little bit. And so the problem with that is if you want to do a registration protocol, you have to change the devices that are publishing services. So your HP printer that you bought 2 years ago is not ever going to do a unicast registration because you can't update it. But there, you know, as again, as Stuart said, there's a strong motivation to do this for IoT networking, and also I think it's a good idea in general. Next slide. So I actually wrote a document for Yokohama. This was a stateful Dnssd document that attempted to outline a sort of a vague idea of how to solve the problem of stateful registration. It was pretty thin. I haven't done any more work on it. The open problems that need to be solved. How do we get a unique identifier per service so that we can tell when? So one of the problems with disambiguation is that if you have a service that appears on 2 network links, and it's the same service, then multicast DNS doesn't provide a way to tell that it's the same service. So as far as multicast DNS is concerned, it's actually 2 services, both claiming the same name. And if you allow for name conflict resolution across multiple links, then what's going to happen is that service is going to start fighting with itself. And so its name is going to just, usually like a number changes or something like that. So you'll see the number just continually incrementing. And so you can never actually talk to the service because it's constantly changing its name. So in order to fix that, there has to be a unique identifier, and this is something that's missing from MDNS. So if we wanted to solve that, we'd really need to have a new protocol for doing updates that includes some kind of unique identifier. Then another problem is, how do we do unicast registration? Stuart is talking about doing that with DNS updates. I don't actually love the DNS update solution, but he and I will talk about that offline, and maybe I'm wrong. And then security, I talked about in the document. Basically, the idea is that if you're a service that's publishing a name, you would generate a key, and you would use that key to sign any subsequent updates. So if some other service attempted to claim the same name, it wouldn't be able to do so because it doesn't have the key. And then state maintenance, cleanup of hosts that have left the network, and renumbering are things that have to be dealt with in the stateful approach. If your network renumbers, obviously you're going to have a big change in your zone. One way to solve the left hosts problem is to do leases. The only issue with that is that it means that a device that you don't leave on all the time, another device could come on the network and take its name, and then man in the middle attack you. So that's a little bit questionable. Next slide. So there's already existing work on registration going on. It's not Dnssd registration, but it's interesting work. And one of the things that I'm hoping is we may be able to leverage that. The core working group is working on a resource directory, and Stuart's been talking about work that the thread working group is doing. So
I just wanted to make a very brief comment on the previous thing, because I don't want to be misleading. The idea of the lease lifetime was to clean records up when a device is really gone. If it's not gone, if it's just sleeping and saving power, the model in my mind was it would wake up once every 2 hours or once every 24 hours to tell the DNS server, I'm still here. Kind of like renewing its DHCP lease, because in the world of DHCP, if it doesn't renew the lease, when it expires, that address is eligible to be allocated to something else. So if that device wants to maintain a presence, it needs some kind of hardware timer to wake up. And the idea is when it renews its DHCP lease, it would renew its record registration at the same time.
Right, so that's one model of thinking about it, but the problem with that model is that, for example, my wife routinely turns off the printer upstairs, and I routinely forget to turn it off because I'm not quite as careful as she is. But the point being that therefore it can't do that because it's been turned off by someone.
Well,
and I'd still like it to keep its name, and for people, for rogue devices on the network to not be able to claim its name.
Let's talk about this. I don't want to take it. If there's more time, we can talk now. I'll sit
No,
down.
no, I don't think there is. I think we should.
We've got about 20, 25 minutes.
Yeah. So next slide. I think this is. Is there another slide? Yes. Right. So.
Which one do you want? This one?
That one. Things I want to do or want done. So I want to figure out how to deal with the disambiguation problem. I think it's a slightly harder problem than the way Stuart described it. That doesn't mean that it's not solvable. But unfortunately, I think that really solving the disambiguation problem requires protocol changes, and that may be a deal breaker. I'd personally like to prototype a stateful Dnssd server, kind of based on what I described in the document that I presented last time. I haven't gotten around to doing that yet. That's code that I'm happy to write. I'd be interested in seeing if anybody else is interested in looking at it and working with it. If you are, talk to me later. I'd like to figure out if we can leverage the core work, and I'd like to figure out if we can support the core work that I alluded to in the previous slide. And then I'd also like to see if it's, I'd like to try to publish a secure zone using stateful Dnssd and see what happens and what breaks and how utterly disastrous it is. So that's kind of my list of projects for maybe before the next IETF, or maybe not, we'll see. So that's what I'm working on.
Okay, thanks, Ted. So we can take questions and points. Will you just save the core and resource discovery stuff till after Inez's talk, maybe? But any other questions or points?
Harry. Yeah, the hard part about doing DNSSEC is that you don't know what you don't know, so you can't do NSEC records. So
Right, yeah, you can't do secure denial of existence for something that you can't securely deny exists.
right. So
Yeah.
if you're willing to leave those out, then you can sign records.
Yeah. Yeah.
And I think another question here is to what extent you can reuse the things that we have as working group items, and therefore what the gaps are.
Right, yeah, I mean,
And-
there's a huge amount of stuff that's already being done
Yeah.
here that can be used.
So
By
to
the way-
clarify what the pieces are that we can build on and what the gaps are. And in fact, I mean, some of the things you've hinted at may actually not be solvable. They may be too difficult, but
Yeah.
I think it's really good to do the analysis and see what the gaps are.
Yeah, and I mean, one answer to the secure denial of existence problem is to enumerate all of the services on the wire. That's an expensive thing to do. It's probably not worth doing, but one could in principle do it. And maybe that solves the problem, or at least does a decent enough job to be worth doing. It's also possible that it's just not worth doing.
Yeah, yeah. Well, I think, I mean, a lot of what you've described is perhaps the word is exploratory, maybe. So, and if you go away and come back and then can propose a more specific draft that addresses a certain problem that fits with what we've done so far and adds extra capability by whatever it is, that would be great. So it's just going to take a bit of time, I think. Okay, great. So thank you very much, Ted. So the last item on the agenda is Ines, if I'm pronouncing the name correctly, who's going to talk to us a little bit about Dnssd and IoT. And we'll mention the resource directory again, I think, if I can find the slides. There we go. There we go. That's still up there. That's interesting. How do I get control? Escape. Oh, there we go. But do I need to move this over there? One's PowerPoint, right, of course. Yeah. Of course, we've got a clicker that you can, I think, use. Okay, we've got 15 minutes or so.
Well, Ines Roberts, in her role for the IoT, received a request for a review of one of the documents here and the interoperability, and she then mentioned about the interoperability with IoT and asked me a set of questions. And then Tim said, oh, these are interesting questions.
I think you need to be a little closer to the mic.
I'm sorry. Is this okay? Very good. So it was all about Ines for the moment. Well, but from one thing came another, and so now I'm standing here to give you a very short 5-minute presentation about the requirements from IoT and how that might affect the Dnssd. That's interesting.
So, okay, that's the right slide. Why it went black, I have no idea.
Magic hands. Okay. So what is the purpose is to discuss a bit the IoT requirements, Internet of Things, especially we want to look at the low resources with constrained resource devices in this context. What do they have? They have unlimited bandwidth. We have CPUs which we are not always as powerful as we should like. The memory is constrained because it costs money. We are in an environment where every cent counts because a cent of billions of devices is a lot of money. So it is rather constrained also for the money purposes. And the power resources, because sometimes we want to have these things stand alone for a few years. So they switch on and off. I think this is usually known. I want to look a little bit in this context on the limited bandwidth, so, and talk about the network load. How to adapt the Dnssd. So one of the things that we are looking at here is to do a Web of Things approach. So we are discovering links. Web links, that means that the discovery is much more fine-grained than services which are done by Dnssd. So also the tables that you want to create look differently then. And one of the things which I tried together with Carrie Lynn, of which a few years ago we already did, tried to make those tables and then did the discovery of those links, and there was quite an enormous amount of data which was being transported. Now, where that comes from, maybe I'm just not very intelligent, or that's in here a problem, still have to look at, but one of the things is, should make sure that the payload is small, because the packets are also very small, as you have to do that. Another thing is the communication reduction. The MDNS, multicast DNS, depends on multicast. This has been mentioned before. That is not maybe very well for the mesh networks. But on the other hand, the multicast DNS reserves that autonomy of the network. So you can switch, make disconnected from the rest of the world, and it will continue working. And so in a future solution where you have this unicast, also having the possibility of disconnecting this network from the rest of the world will be very much appreciated, because it is used for how you call it, setting up the networks, etc. Then I also said the Web of Things approach might be good to look at it for the fine-grained resource discovery. And then one of the questions also asked earlier is maybe we should have a bit of the at the resource directory, which is being developed currently in the core working group, and see if it could be integrated. And the other point was maybe if you have Dnssd options, that if you have different configurations of the network, that the Dnssd adapts itself to the network. You have a very small network where you might want to have other preferences than for a very large network which is standalone, or a very large network which is composed of other networks. Just to mention. So the resource directory that was introduced, well, here Karsten maybe wants to do something, is to reduce the discovery multicast traffic. So you do unicast through the resource discovery, the resource directory to discover your links. There is an endpoint, which is the server actually is a set with a set of resources. And it sends an anticast to discover selected endpoints. So you ask for the name and, for example, attributes that you have on that. How do you populate the resource directory? Either the endpoint inserts itself into the resource directory, which is actually just like MDNS, where everybody properly tells you, this is me, and all the others receive it. But there is also the part where the resource directory is populated by an outside by a commissioner, where you can prepare actually the resource directory offline and then later on introduce it. The endpoint does not have a service name like for the Dnssd, but it has something which is called a resource type, which is registered in Ghana, so you can do your discovery on the resource type, and the resource types are predefined. The resource directory itself is also has, of course, a resource type where they have the core RD, the core RD lookup, etc. Query parameters help to filter selection. So we send out query parameters, which is very different, I think, from the DNS model. So this is the last slide. Ongoing work is how to populate DNS from the RD, because that is a requirement. You have this standalone network, this network of IoT devices. It's connected to the internet, and there may well be applications on the internet who wants to access the services. And then, if you do that, then you need to convert all those links attributes to the pointer, SRV, and TXT records. I think there is quite some work to do on how to define it and make that also a standard procedure. And there has been quite a lot of work been done with Perry. And you need guidelines to do that. And that is the problem.
Yeah. Okay, so we've got five or 6 minutes for a chat before we do the roundup. So yeah. So it's just to provoke some discussion, just to find out what the working group feels we should do in this area, whether or not we recharter, but just to have a discussion about what people think we should do here. Carsten?
Maybe worthwhile to extend what you said. You said resource directories can be pre-populated.
And actually, resource directories are applications. So you can have application semantics somewhere. Somebody can write a resource directory for a special case, for doing something. And that's very important because there may be some authorization aspects coming into the resource directory that really are application semantics and wouldn't be part of a standardized protocol. This is all web here. So this is a web application. We expect application developers to develop resource directories that do interesting things. So this is quite different from a DNS world where you kind of expect DNS is a service that is in some anonymous box in a rack somewhere and works for everyone. So that's maybe one very different flavor of what we're doing here. And
completely from my own experience.
So the other observation is these are all web accesses, so that same application may very well also provide other resources for manipulating resource directory, for accessing the resource directory that are not defined in the standard. The standard just gives you a number of basic ways to register, a number of basic ways to query, and data structures that are expected to be supported. Thank you.
Carrie Lynn, I just want to emphasize that this is ongoing work, not work that needs to be done. We've already proposed in CORE, by the way, let me back up and just say that CORE has a charter item to somehow interoperate with Dnssd.
Okay.
I think we had something to do with working in mesh networks. So what we ultimately proposed in CORE was at least a semantic mapping between some elements that can be stored in an RD, namely things that look like services, and Dnssd records. So the state of that is that it's, I guess, a working group item right now in CORE. And so the work is largely done. It just has to be discussed.
Just out of interest, which area is CORE? Is it internet? Applications, right.
Stuart Cheshire. One of the things that I would love to see here is some concrete numbers.
Yep.
Because there are sort of relative value judgments saying that Dnssd packets are too big and core linked discovery packets are small, but we don't actually see how many bytes each of them are. And there's talk about things like the code complexity. One of the reasons that multicast DNS doesn't include a query language was specifically for resource constrained devices, because evaluating the query language and expecting developers to get that right so you can depend on it is very hard. And that was a conscious decision we made to take that out. And I have a little device. I don't have it with me this time, but I've used it in the past for demos. You can still buy them. I think it's called the Site Player Telnet, little box that connects to Ethernet and has a serial port on the other side, because computers don't have serial ports anymore, so it's a way of connecting to legacy devices. This thing implemented multicast DNS and DNS service discovery in 500 bytes of code. So an actual evaluation of the code size would be interesting, because what I saw on the slides was lots of assertions, but not a single number anywhere to quantify any of them.
There were lots of question marks.
Dave?
Yeah, Dave Gayer, I was also going to bring up the code size point, because I think on the constraints of IoT, you had, constrained bandwidth or whatever else. You didn't specifically call out code, and I think that is one of the key constraints here is what is the code size. So I am a fan of Dnssd, and those of you who are in CORE know that I got up there to talk about how you discover things and how the way that you discover devices in CoAP by default uses multicast that has problems with some APs that the MDNS doesn't. But on the code size point, There's an IAB RFC. It's basically even dates from the time that Stuart was on it. I don't know. It's 6505. It's his Principles of Internet Host Configuration. And there it talks about discussions of, which discovery protocol should I use go way back, even before our time, right? And so that one talks about some principles. And one of the principles, since it doesn't answer that question, is which protocol you should use, DHCP versus RA. It doesn't answer that. It gives some principles. Right? One of the principles is that there are two things that are appropriate, and which one is appropriate for you depends on your constraint. One thing that's appropriate is to use some generic mechanism rather than every app inventing their own. And the other one is to use whatever protocol that you would use for the actual communication. So, for example, to discover the TCP congestion window, you use TCP, right? Okay. And so what this is saying is that the protocol that you're using to communicate with the actual device in an IoT might be CoAP. Okay. And so that means that there are two possible good answers. One is to say, use CoAP for discovery because that means there's only one protocol implementation and I don't care about the code size for anything else. And that's how you get the code size as small as possible, right? And so if code size of, say, MDNS was significant, if it's a couple K or more, you can replace that couple K or more with maybe device functionality for your really tiny, tiny device. Right? On the other hand, it does have these other considerations where you have ecosystems that are built around generic protocols like MDNS that work in wider situations, right? So neither one of those is necessarily the right one, which does argue for there being a way to interoperate between them, which I think was a proposal here and what Terry was saying is the chartered work item, right? So I think there are good arguments for doing this. There's good arguments both ways, and therefore there's an argument for potentially having this proxy thing that Terry and you were talking about.
Okay, so last comment, then we'll have to conclude.
Randy Turner, this is an area that we're working with at my company, and we use a service discovery solution for brokerless PubSub on the smart grid. We have large smart grid apps. Then in a brokerless, normally you go to a broker and a PubSub, but if we don't have a broker, then you need to discover services. And so this might be a nice way to do that in a brokerless PubSub situation.
Okay, yeah, it obviously sounds very relevant both to ourselves and we need to bring together what's happening over in core and what's happening here. So, I mean, maybe one way forward is for some of the people that are here, like Carson and Stuart, Kerry, to sit down and talk this through at some point this week and see if you can come up with any suggestions. I've heard various possibilities mentioned, but if you can sit down and talk it through, that would be great. And let us know how that goes. Okay, so Ralph, I think, is going to just go through the action.
Yeah, here's the summary of the actions for the documents that are in the presentations today. There it is, push notifications. Stuart is going to collect the input on the working group last call for this document. We'll put it aside, see if there's anything that needs to be changed based on the working group last call on the session signal document in DNSOP, and then the Dnssd push document should be ready for the IESG. The discovery proxy document is ready for IESG review. We need to find a shepherd. This would be a nice opportunity for somebody to volunteer to be a shepherd if you'd like to get involved with the process. He says the crickets. Let's see, the discovery broker document, there is, we had several documents in one presentation from Stuart. There was general hum for support in the room to do the discovery broker document. Essentially no objection to the document that documents the sleep proxy mechanism. We had hum in support of the advertising proxy, and the zone stitching. I didn't get a result on that one.
No, I think it's at the moment it's a little vague and it's in its conceptual stages, shall we say? So, but Ted and Stuart have both presented on it in the last 2 or 3 meetings. So we'll no doubt talk further. I think they've been trying to talk since a couple of meetings ago. So.
And enthusiastic support for continuing to develop a Dnssd roadmap for our clarity. Christian's privacy extensions document is ready for working group last call. The device pairing document, we got consensus not to split that document into 2 pieces. leave it the way it is. And it's ready for working group last call after a last revision. We have Stuart, Ted, and Donald volunteering to read it. Encourage Tom to continue work on his document. No actions as a result of Ted's presentations, but we certainly would encourage a more specific formulation of thoughts and continue that direction. Right, and then nothing specific for the last presentation except to encourage people from Dnssd and core communities to get together and talk about how to fit those two pieces together. And I think that's it. If you have any additions, corrections, summaries, I have the blue sheets here. If you haven't signed in, please come up and sign in. And if not, my computer says 6:40, so I think we're done. Thank you all.
Did you sign the blue sheet? I always do as a chair. I sign a blue sheet to make sure the room's big enough, but there's always chairs.